So basically, once you open Matlab, if you have the default layout, if it's the first time you open Matlab, you will see many windows together. If your Matlab is in a strange configuration of windows, you just click on layout and click on default, and basically you're gonna get this. There are other layouts if you find them more useful. Now this is the 2-column layout, but in general, you can then of course rearrange these windows yourself. And then briefly, it's let's go through basically what are these windows. And so in general, Matlab, or at least back in the days, Matlab was just a command window. What it means, if you know what is a command line or terminal or prompt, the idea is that it's as small as possible program that you can have running in a machine, whether it doesn't really matter if it's a Mac or Windows or Linux. And in the command window, you just interact with the machine using commands, typing commands. So for example, now I'm going to type ls, which is telling me which files are here, and there is nothing here. Other commands that you might know from if you're familiar with the command, but they are still useful. It's navigating through the folders. So now I did cd, which is for change directory, and then space, and then dot dot. Dot dot is a secret name for basically saying the parent directory. If you aren't sure which directory you are right now, in this here, you see this is where I chose to be. You might have a different, and you should have a different folder where you are right now. But if you aren't sure, you can always type pwd, which tells you where in the computer you are right now, which basically means that the computer, as a hard disk, as a storage system, and the beginning, this first slash is like the center of everything. In Windows, you might have a letter here, but in Mac and Linux, it starts just with the slash. And then all these are folders nested inside of the other. So here it's just the multiple folders where I am right now. And ls would just tell me, okay, here we have some README file, some folder, and another folder. Okay, so with the command window, we can interact with Matlab. And as I was saying, back in the days, this was the only interface to Matlab. So you just had the command window, and then you were starting your script or typing the command straight to the terminal here. But then with this graphical interface, there are other windows that come along with the command window. So one window that is very useful is the current folder window, which is basically the folder where you are. Not only you see the path here, but here you can also see the content. This is useful because I can pick a file and right click, and maybe I can open it outside Matlab if it's something that I'm not sure, or I can just open it as text. That's kind of the safest often. This, what I have here, is actually the web page that I was showing earlier with all the details. Now Matlab, when I clicked open as a text, it opened this in the Matlab editor and made the command window much smaller, so that where it's difficult now to see. But then this is something that you can try. You can actually resize how much of the editor you want to have and how much of the command window, or you can even undock. In this case, I might find more useful if the editor is not kind of nested or neighbor with all these other windows. So I can click undock, and now the editor has its own window. And in this specific case, it's all this content of the course that we're doing right now. And then another window that is useful is the so-called workspace. So when a program runs on a computer, the program needs to keep some data kind of in the memory. So some data, this is kind of basics of computer science. Some data is stored as files or folders into a hard disk, but some data is actually stored in the memory, in the so-called read access or random access memory, RAM. The idea being that you might need to access these numbers or strings or you're copy and pasting something, that's kind of, so the workspace here, it's a good kind of list of what's in the memory right now. At this stage, there's really nothing in the memory because we haven't defined any variable, we haven't started any script. There is just these ands that I will talk later what it is about. Then, of course, there are other windows inside Matlab, like the history window. So let me try to remember how to check the history window. So now I click here and now I see the command history. So now I have basically, it's like a diary of all the commands that I've typed interactively here. But in general, it's very tricky to work interactively. I can close now this history window. If I'm lost, I click layout default. In general, writing things interactively can be useful. So, you would start defining some variable and doing something else and doing something else. And of course, the history keeps track of what you did, but it might be very difficult tomorrow to redo the same, to go back to the state where you were. So in general, it's very useful to always create a script. So even though you're just playing with Matlab and you just want to run a couple of commands, you can start the editor and start, editing a file. So from the Matlab log, if you type edit and then, I don't know, it can be test script.m. .m is the extension of Matlab files. Now it starts the editor and it asks me, do you want to create this new file that doesn't exist? Yes, please. And now I'm in the editor. And now I can start typing all my commands and, I don't know, whatever we want to do. Now I define x and then x squared. And now I know tomorrow what I was doing and what I was running. I find personally very useful to also start from a clear space, which means I might not sure if I have already a variable x stored in the workspace. Of course, I can double check, but it's even easier if I know that I don't need to kind of, keep what was in the content of my workspace, what's in the memory. It's good to start clear. And so all the scripts that I write, I usually start them with clear all. So delete completely the content of the memory so that we are fresh to start and then start working on something. Another useful thing with the editor, of course, is that, okay, maybe tomorrow you remember what you were doing here, defining x and squaring it. But in a few days or in a few months, you might not remember anymore. So it's good to always write comments. Today, we learn the basic of Matlab. And now I'm actually, basically writing the plot of this kind of script that we're working together. Here below, we define some variable x. So this is more generic about coding. It goes, this is not just for Matra, but somebody advises that the best way to start working with software is to just write the comments. So, if you have a plan of what to do with your data, or even if you don't have a plan, you can just start by writing the comments. In Matlab, the comments are with this percentage sign. Maybe one thing actually I could try to make the font a little bit bigger, because some of you might not have a large enough screen. I just don't remember how to do it quickly, but I can check it in the break. But in general, so the Matlab comments in a script, they will all start with a percentage sign, which basically means that whatever happens after a percentage sign, the editor colors it green. It's basically just free text comments, nothing that will be actually interpreted, nothing that will actually affect numbers or your computation. Just a quick one, there's also if you put two brackets, two percentage signs, you can also have here starts a new section. And you can basically, add kind of separate section inside the editor. All right. So at the end, to quit the editor, you might just, like as a normal text editor, you can actually save. And now my script is saved, and then I can close it like you would close any other editor. And then tomorrow I can actually double click and continue the work that I was doing today. Okay, I see one raised hand on Zoom. If you do you want to ask, do you want to mute yourself, or do you want to ask in the chat? We can have a look at the HackMD. And somebody is asking a good question: when are sections useful? I will show it later, but you can kind of think it that you might want to separate parts of your code so that you know that part A is doing something. In the end, comments and sections, they are not useful for Matlab. They're useful for the reader or for the person who write the code, which basically the reader will be you in a few months when you go back to the code. So having this percentage to start a new section just makes the code clearer for you or for somebody else to read it in the future. But when it comes to, there are some advantages that I will show later in the future when we talk more about the editor, when we have more content to work with. But the usefulness of comments and sections are for you, for yourself. All right, so then now you kind of got an idea of this IDE, of the Matlab Integrated Development Environment. And if you were able to open Matlab in your computer, you should have kind of seen similar windows, and you could have typed similar comments. Then what I'm going to talk now before the break, we're going to do the break at 12:50. So a very good website that recently has been kind of launched by Matlab and MathWorks is the so-called Matlab Academy. One could even argue that, you don't need people like me telling you about Matlab, because you can learn everything from Matlab Academy. So I'm also going to paste the link in the Zoom chat for your convenience. So in general, with the Matlab Academy, if you are logged in, there is some content that is kind of free for everyone, even if you're not logged in. But if you're logged in with your institution account, you're actually going to see something that I see here. So the so-called getting started interactive courses that you can take. Let's say you want to learn about deep learning with Matlab because that's your goal and that's what you need to do for your project. Then there's no best way, in my opinion, than to launch this course, this interactive course, and follow it and learn. If you register with Aalto.fi or SK.fi, you can also do more advanced Matlab courses. Matlab Fundamentals is a really good one, and Matlab also Programming Techniques. It's kind of to have a better code. But there's many courses, you can pick whatever you want. And if you're unsure, you can always contact me, and I'm happy to recommend you which one is the best. But if you are if your goal right now is to get started and just really understand the very basics, and this is also the same requirement if you are applying for a credit for this course, then I highly recommend everyone here to do the Matlab on ramp. So I'm now going to start the Matlab on ramp. You can watch me kind of doing it, and after that you can spend a few minutes to basically make sure that you can do what I'm able to do. So in my case, it says resume because I've been already doing it a bit, kind of it remembers where I left it, but I can always start it from the scratch. So now I click the link, and you should see basically the overview of the course. So these are all kind of parts of the course, and in each part there will be some tasks, except for part 1, which is just a simple video. And basically, you can complete these tasks interactively, and kind of Matlab will tell you when, yes, you did it well, you passed the task, you can move to the next level, or, do it again, or think about it again. It's really useful because you get also feedback on the type of error. Of course, it's still a machine feedback. It might not be as good as sitting together with somebody who has been using Matlab before. But this is also why we're here. So maybe, let's say that this afternoon or tomorrow or whenever you have time to go through this Matlab on ramp, you might come up with questions that are interesting questions and that maybe you won't find the easy answer here. So this is also useful of this type of course, that we're here together, that we can ask these questions together and find the best answer. So now I'm going to show you the course overview, which is just 1 minute. And
hello and welcome. Yeah. This course will introduce you to the Matlab language and show you some real-world examples of how Matlab is used. The course starts by introducing some fundamental Matlab commands, then focuses on importing and visualizing data, and finally provides some projects where you can use the skills you gained. By the end of the course, you'll use Matlab to analyze the light recorded from a star to determine if it's moving towards or away from the Earth. The course should take about 2 hours to complete, but you can leave anytime and come back later. Throughout the course, you'll be interacting with a web-based version of Matlab inside our training environment. It has a slightly different look and feel from Matlab Online or the desktop version of Matlab, but don't worry, you're using the exact same Matlab language. Enjoy the course.
All right, so then basically this section would be completed. I can click next, and in my progress of this course, I would kind of, I've completed section 1. So I think now this is a good moment before starting here, before that I show you this Matlab Academy, and specifically Matlab on ramp, that we could have a break. And the break can start, like the break can be between 12:50 and 13, so that we resume at 13. But in these 3 minutes before 12:50, you can try to logging into the Matlab Academy website with your Aalto email or Helsinki email and click launch the Matlab on ramp and, for example, look at the video, which is the first task that you need to do. So if you were all able to do this, you can then click yes on the Zoom commands. You find the Zoom commands when you click on participants in the Zoom toolbar. There's yes, no, go slower, go faster, and other options. And then after that, we can have a break. And we can resume at 13. One last thing, during the break, if some of you, I know that they are here for also because they would like to get 1 credit, which is good. So if you are here to get any credit, you can send me a direct message on the Zoom chat, basically just saying I am name and surname, and mark me as that you were attending here, because we're basically attending to all the lectures, gives you more hours for your credit points. All right, everything clear? I hope so. And that's it. So test the Matlab on ramp and try to check the video so that basically you are at the same stage where I'm seeing right now, and see you at 13 o'clock. I will now check the HackMD to see if there's any questions there, but I'm trying not to talk during the break, because it's important that a break is a break. All right, so it's 1 p.m. and thank you for those who mentioned in the direct message their name so that I can register them later to make sure that you get the credit with minimum effort and maximum result. So I was saying that it would be good that you can all test that Matlab on ramp works for you. So if you were all here, opposite, so it's different. So if you are all able to logging into matlabacademy.mathworks.com, and basically after that video you should be at this screen. So if you see the same screen that I'm now showing in the screen share, can you please click the yes button in the Zoom? So the idea is that you can actually, if you click the yes button, I can count, or Zoom's gonna count now the 7 yes buttons. I guess that when we reach 13 or 15, I know that more than half are able to see the same screen that I'm seeing right now. This is good to test. I mean, it's pretty trivial, but it's one of those things that it's more important to actually do things, yourself, or rather than listening to me talking.
Maybe you should specify that the yes button can be seen in the participants menu.
Yeah, exactly. So if you click the participants button, you see the list of all participants in this Zoom, and there's yes, no, and other buttons. So thanks, Jan. So I'm counting 10 people are able to see the same screen that I'm seeing with their browser on Matlab Academy. Let's get more yes. 12 people, 13 people. All right, we have reached, the 51% of the voters. Yeah, Matlab Academy is asking me, are you still here? Yes, I am. All right, so then Matlab Academy works like this, that here on the left side, you have a task. And in this case, this is the Matlab on ramp. It's really easy. It's really trivial. Nothing is trivial, I know. But it starts as low as possible. But then for more advanced courses, you will see that, that this task is not as simple as it is. But basically, Matlab is explaining here what I was telling earlier. This is the Matra prompt. So you interact with the prompt. And here you can enter commands. And one command, for example, could be the multiplication of two numbers, or two integers. So 3 times 5. So your task, which is written here, is type 3 times 5. So if you do it with me, you can watch me doing it, but it's better if you actually do it. And then you press enter. Then you get the feedback. You get answer equals 15, which yes, 3 times 5 is 15. And Matlab on ramp is saying correct. You kind of, you've done this part. So then you can basically click next. There's a button. You can click here or or use the spacebar. Then the next task is saying that, unless otherwise specified, Matlab stores the calculation in a variable named ans. This is what I mentioned earlier. So now the workspace, even in this web interface, we have the workspace and there's a variable called ans. And now this variable ans, which is the previous answer, is storing the value 15. So now if we do the task that is written here, assign 3 times 5 to a variable named m. So now we have a variable which is a new name, and it's m, and this is equal the multiplication of 3 and 5. So yes, we managed to pass also this level. And now you see that in the workspace, now you have a variable called m, which means that the content of m is now 15, and it's the multiplication that we did. So now there's a place in the memory with a name that we know, m, and we can access it. And this is useful, for example, if you have a script and you need to name the variables. So as with many other programming languages, the naming a variable is that the variable is on the left side of the single equal sign, and on the right side you have the value that you want to store to the variable. Now let's continue. And now basically, yeah, I went through fast because now it's exactly saying what I was saying, that the equal sign is a way to assign a variable. So here we are getting the task to complete is that we want to increase m of 1. So m, kind of the new value of m, should be the old value of m plus 1. This is what we need to do. If I would have done a mistake, if I would have written now plus 2, so I'm not doing the task that is asking, Matlab on ramp is say, there's something wrong. I'm not expecting to have this number, 17. So in general, you can always look at the solutions. So you can see that I don't want to kind of spoil you the fun. You can continue through all the tasks. And if you want to go back, you see here in this top left corner, you see all the other parts of this Matlab on ramp. It's a fun way of learning Matlab. And if you read everything that is written here, it also tells you, kind of what are these operators, like the equal sign, it's an operator, what are they doing, and what is happening in the background. And if you're lost and if you do a mistake, then you can also see the correct solution that you're supposed to type. So for those who would like to, I recommend Matlab on ramp for everyone, honestly, because it's well done and it's interactive. So it's not just reading, it's actually doing it and learning by doing. But at least for those who want the credit, you need to complete this 100%. And once you have completed it, you can get a certificate. At the end, it will show you have completed Matlab on ramp 100%. I think you can get a PDF out of that certificate and, for example, send it to me. All right, so we are kind of fine with our schedule. And we're now covering kind of the self-learning and self-helping, which is the most important part when it comes to Matlab. There are, of course, other ways of learning and helping and getting help, but often you will find yourself that you will need help straight kind of, from the core, from the function that you are working with. So one of the Matlab functions, I'm not explaining yet what is a function, but basically you can think it of an existing script, Matlab script that can serve multiple purposes. Every programming language has functions, but here specifically, you don't need to understand yet the concept of a function, but in general, you can ask for help to the Matra prompt. So now this is just, I visualize now my Matra so that it only shows this prompt, this command line. And here I can ask for help. I can just type help and Matlab is telling me, okay, which kind of help do you want? And it shows me so many options of all possible toolboxes, if I need help with any of this. But we're just starting, and maybe, we just want to do a plot, and we heard from our neighbor that plot is the function that we want to use. So we just want to know more about the plot function. So you can type help plot, and basically within the terminal, so within the command line, I'm scrolling now, it tells you what you need to know to do the plot. So this is a linear plot, kind of it plots a line. And the most simple thing the way that you can use it is that you have some data stored in X and Y, or just Y, you don't have X. And then you just type plot with this. This is how you call a function. We will see it later. Another way of learning more about a function is also to use the command doc. So if I type doc and then the name of the function that I want to learn more about, now it opens. It basically, what it is kind of a web browser that is running inside Matlab, within Matlab. I personally find it more useful to use an actual web browser, and whether I Google it or whether I visit the website. But basically this is where, what I was showing earlier, this is kind of, where you want to get the real help. So all the content that you get when you type a doc and name of the function, you can get it here. So I could search for plot, and I already saw it there. I was too fast. Yeah, this is the function plot. And here you see kind of you kind of see what was seeing in the terminal in the command line by typing help plot, but it's a little bit more structure. And also here you have examples. So you have bits of code that you can, for example, copy and paste. You know, now for example, I select this bit of code, I copy it, and then I paste it in the main command, and then I press enter, and it's actually running. And now I made a plot of a sign, you know, just like it's there in the example. So in general, it's very useful to learn from the Matlab website. So there is Matlab Academy, which is a more interactive and structured course, but also learning just by seeing, you know, you might have an idea, you might get inspired when you see an example and you know that you want to get the same with your data because you want to do this similar plot. So you know where to start, you know where kind of, you know, which comma you need to type to get to a similar point. Another thing that I didn't mention is that the help section is kind of structured in topics, which makes it easier for looking for a topic where you know what you're looking for, but it also makes it easier to explore topics that you didn't know that they existed. So for example, under graphics, so here they're also kind of nested. So now these were the simple 2D and 3D plots, but maybe, you know, maybe you didn't know about graphic objects. We don't need to go right now about graphic objects, but my point is that you can actually find things that you were not aware about and read more and basically self-learn Matlab this way. It's kind of the hardest way maybe to learn Matlab like this, but it's still more efficient than, you know, reading a book about Matlab. I don't find it very useful. I find it more useful to have a problem and then trying to, you know, get the solution of the problem. Okay, so we kind of covered the self-learning and we even had a look at Matlab on Ramp, and many of you were also able to start Matlab on Ramp and, for example, do the first pages. Now for the rest of the course, I'm gonna use the so-called software carpentry material for teaching Matlab in a way that it's learned by doing, so that you're all gonna do the commands that I'm typing and basically learn by typing these commands. So very briefly, if you are curious about what is software carpentry, so software carpentry is a nice open collaborative project where different teachers, programming language teachers from anywhere, they can contribute. They can write a teaching material because, you know, of course I could have written my own slides, invented my own course, but in a way it starts to become, you know, what is the point if we can work together and collaborate together and build a nice package together. So here you can explore as many lessons that you can take yourself or that can be used like we are using right now to run a workshop. Often the carpentry workshops are done physically so that everyone gets a laptop and go to a room and we try together to basically write what the main tutor is writing and try to get, you know, the same numbers out. But in general, the courses are well done that you can even use them as a self-learning material. So, you know, you might click on our lessons and then just explore what's available. You want to learn about the Unix shell, Git, Python, etc., etc. So now for this specific case, I'm using the Matlab one. So let me actually go to the very beginning. This is a link that is also listed in this link that I've shared with you via email, but for your convenience, I can also paste it here. And 1 second, I can paste it also in the main chat. So this is the page that I'm looking right now. And here it's kind of an introductory page that is telling us what you will learn in this course. So in general, I feel that for this course it's good to not have many prerequisites, but of course it's, I hope or I assume that you will know the concept of file and directory and the concept of working directory, kind of where in the computer you are right now and which files you see from there. And also kind of this, what I already explained, the concept of the command window of MATLAB and how to create and edit and save simple files. Because the best way to learn a programming language is to actually have a problem. So here there is actual data attached to this course. It's a series of CSV files, which means common separated files. What it means is basically that there are tables. There are tables with rows and columns, and there's number stored in them. I don't exactly remember what is this data from. Here they just say inflammation in patients. So some measure of some patients across multiple days, whether it's a temperature or inflammation, whatever, it doesn't really matter. But it's basically a real case for us to get not just one, but many of these files and try to understand, how to try to process them in something that is useful for a more generic data science data project. So what we want to do is basically being able to load the data into memory, do some computations, do some numbers, crunching some numbers, and then of course visualize the results. This is what we normally do when we follow kind of this is the same kind of protocol that we have when we analyze some data and we want to publish it. All right, so now the course has 8 different parts and we will go through all of them. Today we will cover for sure part 1 and 2, and if the timings are like last year, we will also be able to cover a bit of part 3. Tomorrow we will resume part 3 and continue with 4 and 5, and then on the 3rd day we will do this more, I wouldn't call them advanced, but a little bit more complicated. Here it's a kind of estimate of how many hours it takes, but of course things can vary because we want to adapt to our needs. And in general, so if you are lost, if you miss a session, if you are not sure what's going on, you can actually explore these things yourself. You can click on one of the lecture, and just by reading, you are able to get back on track. And you can type when the code is written like this, so you know that you can type it. It's better to type it than copy pasting it, but also copy pasting is allowed, of course. And basically you can just step by step do everything to understand what's going on, read between the boxes, and at the end we also have an exercise that we try to do together. We try not to spy the solution immediately, but then if you're lost or if you want to double check, you then click there and you can see the solution. All right, so let's quickly go to the HackMD to see if there's any questions so far. I don't see any question here. And in general, I also repaste the HackMD link on the chat. So if some of you joined later or lost the link. And this HackMD is also useful because all these previous links that I sent via email, they are stored here. And so, for example, you also have this software carpentry link here. You can actually edit, you can actually write questions even not during the session. So if, tomorrow morning you came up with a question and you don't want to forget it, you can go back to this HackMD link and type it here. All right, before starting with the software carpentry course, I see that there's no questions in HackMD. So what we need to do is that we need to kind of set up the kind of, we need the data from this course. So this is where we are. I'm now going to click on the setup part. And for your convenience, I'm going to paste it on the chat, on the Zoom chat. So what we need to do here is basically, well, hopefully you managed to install Matlab or to have a version of Matlab somewhere where you can also use data that I'm providing to you. So here, then the first step is to download this data from the Software Carpentry website. This is different according to your operating system, but most likely, if you see what I'm doing right now, most likely you need to right click and then save link as. You can also try to click, maybe your browser will ask you to save the data. And then when I click on save link as, you want to store it in a clear folder. You already prepare a new folder, which is empty, and I call it SC, Software Carpentry Matlab. But it's basically good to create a folder where you will store the data that we are downloading here, as well as the scripts that we will run that will read the data and then produce some results. So with Mac, for example, I would click here on the new folder button, but I already created this folder. So for me, I can just press save. And the data is now downloaded. So then you go to that folder. In my case, it's here. And in your case, might be somewhere else. So often this should work for all operating systems. But in general, double clicking will extract the content of this zip file in the folder where you are. So in my case, in this Software Carpentry Matra, or in some other operating system, you might need to right click the file and then there is something like extract here. So in this case, there isn't an option, but in Windows, I've seen, for example, you might need to extract here. So now I'm going to double click and now I have a subfolder called data. And inside the folder called data, I have all these 12 CSV files. Now we don't need to check them yet. We can check them later. But basically, it would be good that we are all on the same page. So if you are able, now I switch on the answers. So if you are able to download this zip file, unzip it, and have a folder called data with these 12 files, please click yes in the zoom button. If you are unable for whatever reason, click no. And eventually you can mention why you're not able to reach this stage. And once again, I'm waiting that more than half of you have reached this stage like I'm showing here, so that you have this data folder, and inside you manage to unzip these
I have a question.
Yeah.
Yeah. So I currently today I need to use the online version, the browser app for Matlab. And do you have any tips on how can I open the data?
It's
how can I import the files to the browser version?
Yeah, I don't remember by heart, but I've seen that. I remember seeing that you have like a 1 giga. Like if you are logged in with your Aalto account, you have some disk space there, some storage. But I don't remember by heart how to upload things. I can check, because today actually we are still kind of it's more in the section 3 that we will actually load this data. But right now, for the beginning, it's not a big issue. So eventually, during the next break at 13:50, I can check how to do that.
Okay, thank you.
All right, I see already 12 people clicked on yes. So at least 12 of you managed to see something similar that I'm seeing here. Let's wait if somebody else, just to reach kind of the 50% magic number.
I think there were also the people who said yes before. So they.
No, I actually cleaned those.
Okay.
I removed those.
I didn't see that.
Yeah.
Cool.
So yes, we are at 16. So 16 of you are able to basically download this data. So now the setup is, we can assume that it's completed, and eventually, you can try to do it yourself. or ask in the HackMD, or ask later if you want to try this later at home. So now we can start with the first part of this course, and it's basically we need to understand how to work with variables. So just to get an overview, here it says that this can last 60 minutes, but in my opinion, I was able, at least in previous years, to compress it a little bit more, not use the full 60 minutes. And the actual exercise is just 5 minutes, so there's not too much here. I'm saying that we can compress it a bit because many concepts I've already introduced them, like the command window and these kind of things. So we can go straight to the actual programming languages. So the idea is that your objective is to be able to navigate along the Matlab environment, which is what we showed earlier, the different windows, and then assigning values to a variable. And after that, identify what type of data is stored into a variable, which here they call them Matlab arrays. We will see what they are, and then read some data from a file. So we're not going to do much with that data. So if you were not able to download those CSV file, it's okay, but you will see an example how to do that. All right, so in general here in this bit of text, I'm not reading it word by word, but it's just going through what I told you earlier at the beginning. So the kind of different windows that we have inside the Matlab IDE, Integrated Development Environment, and how to search for help in the documentation. So we can actually get started with the variables. And you got a little taste of this in that Matlab on ramp that I was showing. But basically the idea is that with the equal sign, we can actually, reserve a place in the memory with a certain value. So now, because this is good that we do it together, so I'm now going to resize my screen so that the Matlab terminal, Matra Prompt, is taking half of the screen, especially the left half of the screen, so that you can actually, use half of the screen as you prefer. Do you want to cover my terminal and just look at the lecture slides from the software Carpentry, or vice versa? But the idea is that we can do this together. So you can use half of the screen for your own terminal, for your own Matlab, and then the other half for checking what I'm doing. I also made the fonts bigger so that it's easier for you to read. So let's first clear a bit. So I typed the command CLC, which basically kind of clears everything. I also recommend typing clear all, so I know that there is nothing in my workspace. And now we type the first command that is typed here. So weight in kilograms equal 55. And then there is this semicolon at the end. The semicolon is an interesting thing. Different programming languages might want or might not need to have a semicolon at the end of a statement. So this would be called a statement assigned to the variable weight underscore kilograms, the value of 55. But in Matlab here, the semicolon also has a reason that if I would have typed the same, and for convenience, I use the arrow up so that I don't need to retype everything. The arrow up just shows me what I've been typing recently, and then delete the semicolon. And basically we are doing this, the next block of code from the software Carpentry lecture. Then you see that the actual, value that is stored in the variable is displayed. So with the semicolon at the end, we actually executed that statement in a silent way. We got no feedback that statement, the statement got executed, but we didn't see anything in kind of as a feedback. Here, without the semicolon, we actually see, basically, we see the statement printed. We see an output as they write here in the Carpentry lesson. So this is the same as, because now we have this variable stored in the workspace. So I could just type the variable name, weight, kg, and then it just tells me what it is. Another way of doing this is to use the disp command that they recommend here in the software Carpentry lecture. So with disp, it's a function, which means display. And functions, as in many other programming languages, have a name, and then they use two round brackets. And inside the round brackets, we want to pass the so-called argument of a function. So the function is a generic piece of code that will deal with whatever we passed here to this function. And in this specific case, we only have one variable in our workspace, and it's weight underscore kilogram. So there is a difference that, for example, when I was typing the name of the variable, the output was like the variable name equals and then the number. With this, it just kind of outputs the number without also the variable name. So these are still useful command when you work interactively in MATLAB, so that you understand, for example, okay, what is right now stored in these variables. Of course, you know, if you have more, there is still the workspace window in the Matlab IDE. So even there, of course, you can already see that you have a variable called like that, weight underscore kilogram, and with the value of 55 store. All right, so, well, basically, if I continue with the software carpentry lecture, this is what we were just saying. But right now we saw an example where in the variable weight underscore kilogram, we stored a single value. So now in this, you know, this piece of memory of the RAM has just a single value. But often we might need to store multiple values. And when we have a kind of a list of multiple values, they are often called arrays in programming languages. Different languages have different ways of specifying arrays. For MATLAB, the way of specifying arrays is with square brackets. So now we want to define a new variable, a, which will be an array. So it means that it's a set, it's a collection of variables, not just a single variable. And for that, we will use the square brackets. In this specific example, we want to have 3 values in this variable a. So 1, 2, and 3. So now when I press enter, now there is no semicolon at the end, so I should also be able to see the output. And yes, we see that now there is a variable called a, and inside it I store 1, 2, and 3. You can double check it in your workspace, because now there you have a new variable called a. You see the values. There's only 3 values, so it's able to show you the values. And now it actually tells us also the size, which is the size of this array. So it's like 1 row and 3 columns, because this is exactly what we inputted here. In a similar way, of course, we can create matrices. The mat in MATLAB is actually, it's for matrices, with the main idea, the core idea that all the data structures, I mean, it's not as simple as this, but let's say all these, most of the data structure in MATLAB they can be reconducted to matrices, to arrays. So a matrix, you know, it would be basically saying that it's like if an array is a matrix with only a single row or a single column, a matrix would have more, you know, kind of 2 dimensions. It can be 2 times 2, or in the case that we're going to do here, it would be a 2 rows and 3 columns. So now we do the same example, and I encourage you to type exactly what I'm typing here, because that's the best way to learn. So here in this matrix that we define now, we actually use the array A, and then with the semicolon, we are basically telling, okay, this was the first row of the matrix, and now append the second row of the matrix. So now the semicolon starts to have another meaning. When the semicolon was used at the end of a statement, it was basically suppressing the output. Now the semicolon is used within the statement, specifically within these square brackets. And here it kind of is telling us, you know, make a new row. Like, you know, we have a new row in the matrix. So the first row will be the array A, and the second row will be these numbers that we have inputted. If I press enter, now we see that we have a matrix B where we store these 6 values in this dimension. Something to bear in mind about arrays and matrices is that all values in an array must be of the same type. So in this case, all the values in the matrix and in the array, they're all integers, they're all numbers, and that's okay. In other cases, we might have that, each of these values, they would be all strings or all some other data type. There is, of course, a way to convert numbers to strings, because sometimes we need strings out of the numbers. And here, for example, they mentioned this function, which is num to str, num to string. And if we pass the array A, we see that, yes. So now the difference here is that this is now a string, the output of this function. If you aren't sure what the function is doing, you can always type help num to str, number to string, and then you wait a bit, and then you see all the options that this, num to string is a function that converts some numbers that are passed here as x into their textual string representation. All right, so now if we go on with the I will check later if there's questions in the HackMD, but we continue a little bit so that we get to something a little bit more interesting. So now that we have a numeric value stored in a variable, we can do some math with it, because that's why we're here. We want to process these numbers. So specifically here now in the next example, they want to define another way of storing the weight in a different metric, not in the metric system, in whatever they're called, pounds. And the formula would be that the weight in pounds is 2 times 2, 2.2 times the weight in kilogram. If you feel like, you can of course copy paste the code from the software Carpentry example where my mouse is right now, but it's good to type it. It's better for the learning. So after that, maybe this I'm gonna copy paste it because it's a long line, and here it will just display a string that says weight in pounds, and then attached to the string another string that is the conversion of this number, weight in pounds, into a string. So this is interesting case here, because now you see that there's a square bracket here and a square bracket there. So this is actually an array, and this is the comma in the middle. Is an array with kind of 2 elements. And of course, we just said that the elements have to be of the same type. So if this is a string of text, usually defined with this single apostrophe, after that, we also want to have another string, specifically a string, a number as a string. So now if I press enter, we see what we are supposed to see in the output, so that the weight in pounds is 121. So this is what I was here. They're basically writing what I was just saying, that in this single command of this disp, we have combined the knowledge that we understood from Matlab arrays, and also the fact that there are different types. There are numbers and there are strings, and arrays should contain all the same types. There are other types of data structures that can contain different types, but in general, in the most common cases, at least at the beginning, we are dealing with the arrays and matrices that all contain the same type. So yeah, so now the course continues, and they say that we can change the value of a variable by assigning it a new one. So for example, let's refresh our memory and see what was stored in weight underscore kilogram, and that's the value 55. And now of course we could define a new one. So the weight underscore kilogram is actually equal to 57.5. And now I press enter, and yes, so now we lost kind of the previous value that was stored in weight, and now we only have the new value of weight. Assigning a value to one variable, of course, does not change the value of other variables. So which means that if earlier we specified that the weight in pound is 2 times 2 of the weight in kilogram, now the weight in pound is not being updated with the new weight in kilogram. So now the weight in pound is still storing the old one. So if I type weight in pounds, it's still 121 pounds. So, as they write here, weight in pound doesn't remember where it comes from. Weight in pound has no knowledge that it's defined as 2 times 2 times the variable weight in kilograms. So then the only way to kind of refresh, update the content of weight in pounds is to rerun this command. So we would need to rerun basically, this exact command, so that now we have the new value of weight in kilograms and we get the current value of weight in pounds. All right, now that we know how to assign values to variables, let's view a list of all the variables in our workspace. At the beginning, I introduced you to multiple windows of the IDE, and so of course the workspace window that I'm showing you here already gives us all these values, all these variables, and even their size that I mentioned earlier. But there are other ways of getting these, and for example, there's the command who that basically lists all the variables that are now present in the workspace. I'll prefer the command who's with the S, ending S, because it's a little bit more detailed. It's very similar to what you get with the workspace window. So now we see the multiple variables that we have right now stored in the space in the workspace, and also their sizes and also their type, which here specifically they're called classes. So maybe it's not important right now to go into the different types. If you might have taken any computer science or programming course in your life, there are basically different ways of storing numbers in a machine, in a computer. But the idea here is that by default, the numbers that are stored in Matlab have so-called double precision, and the letters, kind of the, how can I say, the strings, they are kind of characters. So this is kind of all you need to know right now. So basically, yeah, this is what I already mentioned. And now let's have a little exercise. And it would be good if you all do the exercise, or at least most of you, so that, so that we can then check if we did the same with the solution. Here they're saying predict what variables refer to what values after each statement in the following program. Of course, this is an exercise that's not that fun to do alone, maybe. So I'm gonna do it here with you. So they first define a variable called mass, and they give it a value of 47.5. You can type with me if you want. All right, so mass now has this value. Then they define age, and they store a value of 122. All right, so now in this statement, if I'm going to type mass equal mass times 2.0, I guess, does anyone want to say or write what would be the answer, or should we just trust Matlab, especially because we don't want to start doing floating point math? But basically, if we type this, now the value of mass will be updated. This is the new value of mass, takes the old value of mass and multiplies it times 2.0. And yes, now the value of mass is 95. And the same would go with the variable age. So if age was set to 122, what would happen if we take the old age, remove 20, and store it into the new version of the variable age? Let's see. I'm pretty sure you all know what's going to happen. And yes, age has decreased. So now age stores, a new value, which is 102. We can verify the solution with some discussion here, but basically, the key point is to understand that the expression to the right of the sign is evaluated first, and then the result is stored to the left part of the sign. So, this is why I mentioned this is the old value of the age variable. This part is evaluated first, and then it's passed to what happens on the left. All right, so we could have now, we're soon getting closer to our break. I quickly checked the HackMD if there's questions, but I don't see any questions right now. And of course, you can unmute yourself if you want to ask something. But if there's nothing major, we can continue so that we can get a little bit more out of today. So here, we don't really need to go into the details of this section, but if you are interested in good practices for project organization and specifically data management for research projects, there is a very, very good paper written by the same people here of the software carpentry on, the fact that it's good to keep the data and the code separated from each other. So long story short, what they are recommending us here to continue with our course is that, yes, we have a folder called data right now, and here it is. But in the same working directory, we should also have another folder that we should call results, so that the data folder is kind of the input of our system, of our code that we are building, that we're writing, and then the results folder will be a separate place where we will just store the output. This is a good practice of data management. You can read more about it here. In general, actually, we have a nice series of courses in Aalto about data management. But for now, what we basically need to do is that we need to create a subfolder called results. So you can do it, of course, in whatever is more convenient for you. You can go like here that I'm showing in my operating system. I would right click and create new folder and call it results. If you want to learn to do it in Matlab, then in Matlab it's mkdir, like make a folder, make a directory, and then the name that we want to create is results. So now when I do ls, I can see I was in the wrong folder, sorry. Right here. So when I do ls, I can see that right now in my folder, I have a subfolder called data, subfolder called results, and the zip file that I downloaded earlier. So you should approximately have something like this. Then with cd, we change directory. I can go inside the data folder. You see that this also gets updated here in the top to remind us where we are. And with ls, I would be able to see all these comma separated value files that we downloaded. And with cd ... we go back to the top. So now this is like one way. There's many ways in Matlab to load external data that we have downloaded. And one function to do this is the read matrix. So it's actually, honestly, I don't usually use this function. I prefer the more generic load, but why not? There's nothing wrong with this function. And if you want to know what this function does, you can always type help. Yeah, I don't understand now why. Read matrix. I would just not use read matrix. I would just use load or CSV read. I'm not sure now why in this course they have read matrix. Maybe it was some older version of Matra, but anyway, so maybe we do it our way, and now we type the line that we're supposed to type, patient underscore data equal load. And now here it's a string. So if you remember, I mentioned earlier that when we have this apostrophe, there's a string, and the string that we want to pass here is kind of the path to the file. So where the file is located, specifically it's in a subfolder, and this is a way to specify the subfolder that I see under the place where I am right now, and then the name of the file. Specifically, we want to load the first one, so inflammation-01.csv. So what this command does is that it loads this CSV data with this data that is stored in this comma separated value file and stores it in the variable called patient data. All right, now there was I didn't have the semicolon at the end. So now it actually showed all the data. If I run it again without the semicolon, now we know that it's there. And we can run the same command that we ran earlier, was, and now we see that we have a matrix. We wrote the matrix with 60 rows and 40 columns, and they're all double values. Now it's 1:50. It's good to have a little break. If you have questions, of course, you can unmute yourself, but you can also keep on using this HackMD so that the questions are documented and we can keep them for the next days. And basically during the break, I'm gonna try to remind myself how the Matlab Online was dealing with this files. But if you have any questions, you can ask. Otherwise, we go back here at 14 o'clock.
I have a comment.
Yeah.
So yes, so it was very easy to upload the files. The upload option is in the browser window. It is on the upper tool banner on the left, close to the home option. In the home tab, close to create a new script, new file, new folder, those options.
All right, that's good. Okay, so it's 2 p.m. We can resume our software carpentry Matlab course. There were two good observations in the Academy that I'm screen sharing as well here. So you have noticed that when I was trying to run the same code as specified in the software carpentry course page, they were mentioning this read matrix, and somebody here is actually able to run the read matrix function. So then I started to wonder why in my computer, what I typed here, which read matrix, the which command would tell you which function is that. So if I would do which plot, it would tell me, yes, we have plot and it's stored in that location. So then I went to check in the Matlab website and I typed the read matrix function and it exists and it's there. And then when I scroll to the very bottom, then I can see that, where did I see it? That this function was introduced in version 2019A. So this is an interesting case that last year when I was given the same course, I guess that the teaching material from the software carpentry was still using load or CSV read, but now they have updated it to a more recent version of Matlab, and my version of Matlab is 2017. So if you have the version of Matlab that is 2019A or after, you don't have any issues with that. And then someone else was mentioning that sometimes these buttons, whether it's backspace, delete, insert, and even Control V and Control C, sometimes in Matlab they don't behave like they would normally behave. Let's say that Command C or Control C is your standard way of copying. But this is something that I noticed that some version of Matlab has different kind of default settings that are not matched with your operating system. I don't know now the specific case why for this person the backspace was not working, but you can explore these options in preferences, as I'm showing right now, and keyboard. And here you can basically look at the shortcuts. And I recommend to set them as you have them in your operating system. In this case, it's a Mac, but the same applies. Otherwise, you might have some different behaviors that what you normally would do with your operating system is not actually working with Matra. But eventually we can investigate more deeply what was the reason. All right, there's no other other remarks from Mackenzie. You can feel free to write there. I repaste the link to the chat for your convenience if you joined recently and you didn't have the link. And we can continue and finish this part one of the software carpentry course. So yeah, basically where we are right now is that we were able to load the data, and now in this patient data, as I wrote here in WUS, now we see also the size. General size is a property of the data, but it's also a function. It's a very useful function, kind of, to investigate what is the data that you're working with. So if I then type size patient underscore data, and if you just type the same, you get the number of rows and the number of columns. If this, now in this case, we have a two-dimensional matrix, so we have a table and we have rows and columns, but imagine if this would have been a volume, the size would have returned 3 values, kind of the 3 dimensions for a volume, etc. for multidimensional data. Then this first part of the software carpentry Matlab course ends with the quick reference of kind of what we mentioned earlier of the classes. So here with the command WUS, you already see in one view at a glance the type of classes for all the different variables that we have in the workspace. But in general, you can always type class and then the name of the variable, like patient data, and it tells us kind of what is the type of the data stored here. This goes to what I was mentioning earlier, that in computers, there are different ways of storing numerical data or any other type of data structure. So it's good to be aware, often you are fine with double and you are going to deal with other tools that are going to use doubles, but it's good to be aware because maybe sometimes you start, digging into someone else's code and you don't understand why the behavior is strange, and maybe you didn't know that what you thought was a double value number, it was actually this. For example, here they mentioned this int 16. But in general, I wouldn't basically worry too much about these things now, except being aware that they exist and they can be important sometimes. So this section is over, and the key points to remember is how Matlab stores data in arrays, and for example, how to read data that was stored in a CSV file. Now, let's try to complete at least this second part. We should be able, because the teaching time, recommended teaching time is 15 minutes, so that we can already start also with a bit of the third part, and we are in time with our schedule. All right, so we looked at arrays, and they were, of course, very useful and very interesting. We now, for example, managed to get an array of this patient data for this specific project. But then, of course, sometimes we might need to the so-called array indexing. We might need to access a specific location in the array. So, if these are, I don't remember exactly the rows and the column in this patient data, but let's say that the columns are different patients, then maybe, you might want to access only a specific one, a specific column or a specific row. So this is called array indexing, and it's quite an important concept also because it's not exactly the same as in other programming languages. But let's first try to learn this with an example. I personally find it more intuitive. The way that Matra puts it, it's more closer to how we express it as a language. So take the first row, then you want to have the row number one. But in other programming languages, these types of indexing, the first row might be called 0. So now we try this magic function, which is a funny function. So m equals to magic of 8. And if you're curious about the function magic, it's a so-called magic square. So it's an n by n matrix constructed from all the integers that goes from 1 to the number, in this case 64, and so that all the rows and all the columns, they all sum to the same value. So this magic function produces a, in this case, for this our purposes, it's just a way to generate some random matrix with some values. So basically what we have in memory right now is all the values, this 8 times 8 that you see also here displayed in the terminal. And now, if we want to access specifically here in the example, let's say the value 38, the value 38, let's see in which row. So it's row 1, 2, 3, 4, 5, and let's see which column, 1, 2, 3, 4, 5, 6. So to get this value marked in blue in the teaching material, we should type M, capital M, which is the name of this variable where we store the magic. And then with the round brackets, which is the same operator that we have been using for functions, but now M is not a function. Now M is a matrix. And here we specify the row coordinate and the column coordinate. So now we're saying from this matrix that is 8 times 8, give me the value stored in row 5, column 6. And it's 38 as it's said here. So of course this is useful because we might need to specifically check one value from our data and whether we need to use this value for something else or double check it interactively like we did here. But sometimes we want to get, for example, the whole row. We want to access a whole row and not just a single value. So Matlab has a special operator specific for these purposes, which is the equivalent of saying, give me everything. So in this task that they define here, we would like to get the fifth row number 5. So then from the matrix M, we want to get row number 5, but we don't have we want to get everything from the beginning, from the first column to the last column. So with this operator, with now, it's not a semicolon, it's a column. So here's like say, just give me everything based on the context. Here the context is that it's in the position of columns. So just give me all the columns, but stick to the row number 5. So now if I click this, if I enter this, yes, we see exactly the values that are highlighted in blue, 32, 34, 35, etc. And this is the same here. And then of course we might need to get more elements at the same time, because now we were getting, for example, all the values of the 5th row, but maybe we want to get a kind of a slice of the matrix. You know, let's say the first 5 values and all the columns. So it's kind of say, you know, we want to slice the matrix in 2 and just get the top half. So Matlab has another notation for this operator, for the column operator. And specifically here, they want to get row 1, 2, 3, and 4, and all the columns. So the operator is 1 column 4. If I just type 1 column 4 and press enter, you actually see that it basically gives me all the integers from 1 to 4. So included, with the extreme included. This is different than in some other programming languages where you might type a similar notation, but you're going to get 1, 2, 3. So you're not going to get the 4, for example. But in Matlab, it kind of includes the borders of the interval. So similar, if I would put 1 to 10, I would get all the numbers spaced of 1 to 10. So let's do what they ask us to do. We want to get the first 4 rows and all the columns. And exactly we get what they also see here in the teaching material. Same thing, of course, is the other way around. Maybe we want to get all the rows and just some specific columns. Then it's the similar thing. So I could say, for example, that we want all the rows. And in this case, we want to have column 6, 7, and 8. So I could type it like this, 6 to 8, because 6 column 8 would just give me 6, 7, and 8. And if that would work. But sometimes maybe we don't remember that there are 8 columns. We don't know what is the size of the matrix. Then there's another interesting and useful command, a useful kind of keyword, which is the keyword end. End is another keyword that has multiple meanings in different contexts. We will see it later that end is also used to finish a function or finish a for loop or finish a conditional statement. But right now what we need in this specific context, when it's inside of this slicing of matrices, end is the equivalent of saying, give me the size of the place where you are. So now this 6 to end is the equivalent of saying 6 to 8, because end in this context would know that the size of M is 8, 8, so that the size of the column specifically it's 8, and which knows which number to put. Finally, the case that they show here is where you want to slice it in a more, you know, that you want, for example, take a little square out of this big matrix. So we have kind of a list, a series of indexes for the columns from the rows and a series for the columns. So specifically, I'm not going to copy paste it from the teaching material. Now we identify the little square that is between rows 4 and 6 and columns 5 to 7. And that's exactly what we see here highlighted. So basically what we've been engaging right now is so-called slicing. However, there is a little bit more advanced slicing that sometimes, you know, now when I type 1 column 10, I get all the integers, all the indexes from 1 to 10. So they're like saying that the jump between each data point is of size, is of 1. But sometimes we want to jump every 2 or every 3. So the column operator actually is handy, because if you have 2 of them and in between another value, you can specify, tell me how much you want to jump. So now by doing this, it will start from 1, but instead of just adding 1 to get the next value, it would add 2. So now this vector here, this array that we would generate like this, would be 1, 3, 5, 7, 9. Let's test it. Yes, it's 1, 3, 5, 7, 9. So starting from 1 with jumps of 2, try to reach until the 10. Of course, it doesn't reach, it doesn't output the actual 10 because 1 plus n times 2 can never be equal to 10. If we would have put 11, then this would have worked and we would also have the final number. So long story short, we can kind of, extract more complex patterns out of the data. So here specifically, here I gave you the example of jumps of 2. Here they want to do jumps of 3. So they're basically saying that the rows that we want to get from this matrix have to start from row number 2 with jumps of 3 until the end. And the columns should be all of them. So if I copy paste the command that they run there, yes. So now we were basically jumping with jumps of size 3 and getting all the columns for this specific case. And then we can even we can do these bigger, larger jumps also in the columns. So now we would get this kind of checkerboard pattern, which would basically mean get the data, with specific jumps. I see that in the rows, we are jumping every 3, and in the columns, we are jumping every 2. So then, yes, this would be, the with jumps of size 3 for the rows and jumps of size 2 for the columns. Again, I copy paste, and I hope you can do the same and verify that you get exactly those numbers marked in blue in this magic square. So all this series of kind of, getting a subsection of an array or a matrix is called slicing. As I said earlier, many programming languages have different ways of slicing, and it's in general, it's one of the most common things that we need to do with the data. Get a subset of the data, get just the first part, or, So here in this little exercise, they define something interesting that so far we've been working with arrays that were storing numbers, although we also saw a simple case with an array storing characters, so like a string. Here, in this example, in this little exercise, they're showing that we can also slice strings. So it's not that because everything is an array, everything is a matrix. So of course we can, even an array of strings of character, specifically in this case, it would be a matrix with with this 1, 2, 3, 4, 5, 6 values, oxygen. All right, so what is good now for you is that you can try to solve this exercise by yourself, and let's count some 5 minutes. I will try to be silent for the first 2 minutes, and then I will try to do the exercise here, so that if you are blocked or if you're unable to do it, you can watch me doing it. But you can basically read it here and try to do it. If you were able to do it, I don't know how and I don't care how, but if you were able to do it, just raise your hand to, or sorry, just click the yes button. All right, so I'm going to try to be silent for 2 minutes so that you can try to solve this exercise. You can cheat, of course, if you click here in the solution box, but it's fun maybe to try to solve this yourself if you're just starting with Matlab. And in 1 minute, I'm gonna start trying it myself too, without checking the solution. At the beginning, at least. So we need the variable called element equals to a string called oxygen. All right. And then we need to display the first three characters of oxygen. So this array of strings, then there is a first string that says first three characters, common, and then we slice the element array and we want from 1 to 3, the first three characters. And yes, the first three characters of oxygen are oxy. Then we want to have the last three characters. So I'm lazy, I clicked arrow up to get the previous comma. And I type last three characters, and this is a string of length 6, so we have to go from 4 to 6. And yes, we get it correctly. So then the first question would be, what is the value of element 4 to till the end? Well, because we know that the size of element is 1 row and 6 columns, so it will be the same than element 4 to 6. And we can try it ourselves, element 4 to end, and we get again that again. And then they're asking us, what about element 1 with jumps of 2 until the end? So let's try it out. 1 with jumps of 2 until the end. And yes, makes sense, it's correct. It's getting basically the letters storing odd locations. And then it's asking a little bit, something a little bit more convoluted, which is element starting from 2 until end minus 1. So end knows that it's equal to the size of the element here, which is 6. So that is the equivalent of going from 2 to 5. So element from 2 to end minus 1 should basically equal to oxygen without the O and without the N. And that's correct. Then the second part of this task is saying for any size array, Matlab allows us to index with a single column operator. This can have surprising effect. For instance, compare element with element column and the size of element and the size of element color. So let's try element with just column. That would basically mean give me everything. And now, oh, they are reshaped. It's not a row anymore. It's now a column. And the same would be with the matrix M. So if I type M with everything, and yes, now our M matrix became a vector, a long vector. So I can spy the solutions, and basically we did together what we were aiming to see. So before continuing, were you able to do this simple exercise? Or where nothing is simple until it's done, but did you experience any blockers, or do you feel that something is unclear? Let's say that if you can click the yes button with the Zoom interface, then I know that you were able to do this exercise, or at least look at the solution. I can see already 7, 8 people already clicked yes, 10. All right, so basically looks like that half of you more or less were able to actually test this exercise. And as I said, no pressure, no stress. You can do this with your pace later. Everything is accessible, is public, and you can go through these learning materials by yourself. But this is a good moment, to discuss if you have questions. Actually, let's quickly check the HackMD. But I don't see any new question here. All the questions are in blue, if you noticed, and then when I answer, when I indent, the color changes, makes it a little bit easier to read. All right, so we can continue now then with the part 3 of our software carpentry. So we are perfectly on time. And so now here, in theory, it would take 30 minutes for this part, but from experience from last year, we will not be able to finish it all in 30 minutes, and which is okay. Let's start it, but then let's still reserve some few minutes at the end if there's question, and also to get some feedback for your expectation on this course and how the day went and things like that. All right, so now it's an interesting thing that it's about plotting. This is kind of something that's very important when dealing with when doing data science, that you should always plot your data. Sometimes might be very challenging because maybe the data is huge, but try to plot a slice of your data. Try to get an understanding of what is actually stored there. So in this course material, they try to follow what we normally do often when we work with research projects. And so we have been given this data, and we would like to see what is stored in this data and what are the properties of this data. So we want to kind of analyze the data and visualize some of the analysis and visualize the data themselves. So in first thing that is nice to check with data is, of course, getting an idea of the generical of the general statistical summary statistics, as you want to call them. So for example, at the beginning you might just want to see, okay, what is the mean value of all the data? So now the variable patient data that you should still have in your workspace, I'm gonna type size of patient data to make sure that it's still there. It's still there, and it's 60 times 40. So now, if you remember what we just saw, that if we just specify this column operator, and make it a bit bigger so that you see better. So with this column operator, we would actually basically reshape this matrix into a single long column containing all the values. So if I would do size of patient data with just the column operator, now I'm expecting to see as many rows as 60 times 40 and just one column. And this is what it is, and this is correct. So basically what happens here is that the mean function is called and all the values are passed. So let's try to do what they did there. Mean patient data and all the values stored as a column. And yes, we get the same number. So what would happen here right now? This is the so-called arithmetic mean. So the average of all those numbers. And right now we are just looking at the global average of all the numbers, not specifically per rows or per column. If you then want to, it's good, of course, to understand what is this mean function doing and what might be doing when we have matrices, for example. So here they recommend us to type help mean to get an idea of what the mean function is doing. Or you can go to Matlab website and see it there. But basically what is interesting and what is expected, that in the case of a single array like we have here, mean is just the arithmetic average. So the sum of all the elements divided by their number. But things get a little bit more interesting when instead of having a single array, a single dimensional vector, you start having a matrix, because the mean can be defined along the columns or along the rows. Now, so there are, of course, we will get later back to this, but already here you can see from the help that the mean of x, and then with the parameter dim, takes the mean along the dimension dim, so the value, first dimension, second dimension, or whatever the number of dimension of your data. All right, there are of course other descriptive statistics that we can get from this data. And for example, here in this bit of Matlab code, they would first display kind of, the content, the label of the data that we are getting. There's interesting actually that there's a typo here. They forgot to put the ending apostrophe, so we can submit a fix. But basically they're all calls to the disp function, so that it basically just displays. And in the first one, it displays just a string maximum information, and here is just the maximum of all the values that we are stored. then the minimum, and here the minimum all the values, and then the standard deviation. So the standard deviation across all values. So far so good. You can test this yourself, but you understand that we're gonna get exactly the same number. Now things are getting more interested if, okay, we looked at these global properties using kind of ignoring the shape of the matrix, but then things starts to get more interesting when we might want to preserve the shape of the matrix. So right now it looks like that every row is a patient. So then yes, maybe we want to get only patient number 1 and kind of investigate the maximum for patient number 1. So first we do some slicing that we showed earlier. So we want to have a new variable that is patient underscore 1, and it has to be equal to the whole patient data. You can try this yourself as well, but only keeping the first row. All right. So let's have a look now at the size of patient 1. And yes, it's just a single row with 40 values. And now we can look at the max of patient 1. So it will be just the max of this row, which is different from the max of all the data, which was bigger. So in this specific case, patient 1, the maximum value stored for patient 1 is a little bit smaller than the global maximum. Here in this example, I didn't do it like them, but you can understand that this command disp and then maximum inflation for patient 1 would just be the display of a string, and here it would display the number 18. Here instead I've used it more interactively. So of course, I mean, now for clarity of reading what I mentioned earlier about the comments, for a more clear code for clarity, we have defined patient underscore 1, but in theory, we are, for Matlab point of view, it's not necessary to have a variable called patient underscore 1. We could just pass immediately the variable patient underscore data first row to the function max, and the number would of course be the same, the output. So patient data row 1, all the columns, and now yes, we get 18 like we got earlier. And here comes what I was briefly mentioning earlier, that sometimes, we might want to look at these values for all the patients, for example. The other dimensions are days, or maybe across all the days. So then it's not anymore the maximum, the global maximum, but we want to get a maximum value for each, for example, patient, or a maximum value for each day. Or it can be, I mentioned the maximum, but it could also be the same with the mean. This is what I was showing earlier, that in the help of mean, you can also specify the dimension where the mean should operate or the maximum should operate if you have multidimensional data. So basically it's exactly this, that Matlab allows us to specify the dimension that we want to work on. If we ask for the average across the first dimension, then we want basically to have a, the first dimension in Matlab is always this one that is plotted here. So if we want to have the mean along the first dimension, we would basically get one value per column. If we want to get the mean along the second dimension, then we would get one value per each row. So let's test it. Now let's remember the size of our patient data, and was 60 rows and 40 columns. So the mean of patient data on the first dimension, now this will output a vector that contains the mean for every column. I don't want to output the vector, I'm just going to check the size of this vector. And yes, we have 40 columns, we have 40 values, but now there's just one row, because now the 40 values that we're storing are the mean for each specifically days. These are 40 days. But of course, the same thing can be done across patients. So, but now the mean operator, instead of operating along the first dimension, would work across the second dimension. So now I put 2, and now I have 60 values, 60 rows like we had, but just one column, because we have kind of averaged one dimension away, and we have a single vector. And this is basically, what I was just mentioning. So we can, and also here they did, I was already one step ahead. So, all right, so basically, okay, we got some properties of our data. We got the mean or the maximum, global mean, global maximum, maximum per row and per column. But sometimes it's also useful to visualize the data so that, you know, it's to get a clear vision of what's stored in the data, which is often very important even for kind of quality control purposes. So right now, without going too much into the details, they give us a quick example on how to visualize a matrix, so a two-dimensional data table like we have here. And it's this function, it's a Matra function called image SC, where SC stands for scale. So what this function does is kind of, well, let's run it so we see it with our eyes. Image SC, you can do the same, of course, and you should. Patient underscore data. All right, so now Matlab, you should, if you run this, you should now have a new window, which is a figure window. And now in this figure window, you would have basically the same figure that you also see on the web page of the learning material. So now this is a way of visualizing this two-dimensional data. So we still see the 60 rows, and they are in this Y direction, and we still see the 40 columns in the X kind of direction. And then in each location, we kind of look at the color so that we know that, you know, some given the color, there would be a value store. Now we don't know the mapping between colors and value. Now we don't know if dark blue means 0 or if dark blue means 1 million. So what is useful is to type another command called color bar. And now if I go back to the same plot that I had earlier, now we also have a color bar. So now I know that when I see this very bright yellow, it's actually a value of 20. So there I have a value of 20. And when I see this really dark blue, there's a value of 0. So this is the equivalent of kind of, you know, typing, kind of looking at the matrix here, patient data. But, you know, here it becomes a bit difficult to try to, you know, see which one are the most intense and which one are the least intense. Here at glance, we can see that, okay, if these were days, if these 40 ones were days, it looks like that, for example, at the beginning, at the first day, everyone had the value of 0. And in the middle, on around the 20th, 21st day, many patients had the high value, up to 20. Of course, always label your axis. Never trust anyone who is not labeling their axis. So carefully here, they said that we want to give a title to this image, inflammation, and we want to label the x-axis with the function xLabel, and these are day of trial, and also y-label, which is patient number. So these are all strings. And now if I find the window again, so we have a string for the title, and then a string for the x-axis and for the y-axis. So x-label and y-label. In their teaching material, they didn't use the color bar command, but in my opinion, you should always, I mean, it's good to show the color bar because it's good to know what are these values. It's important to know what are these values. I briefly mentioned earlier that the command that we ran to plot this was image SC. Here it is from the history. What I did here, I started to type the command em, and then I clicked arrow up so that immediately it took me to the most recent time that I typed something that started with em. And this image SC, the SC stands for scaling, which basically means that the data was, the colors were scaled so that the most intense, which is 20, got the brightest color, and the most, the minimum, in this case 0, got the darkest color. So there are other ways where you can kind of specify, for example, the range that you want to have. This is important, for example, if you have multiple plots and you want that they all have the same color bar so that it's not misleading to compare plots. But this is more advanced stuff. We don't need to think about this right now. All right, so then we had a glance, a large look at all the data using this image sc function. But of course, it would be also interesting to kind of, look at this, for example, at the mean values in time. So if each of these 40 values were days, maybe we want to have a plot like this, that for each day, we want to plot the mean across patients, because we don't often care about the single individual patient. We want to get an idea of the, in this case, average. And this is exactly what happens here. So the mean of patient data across the first dimension is exactly this, that will produce for each column, for each day, will produce a value. So mean across the first dimension of patient data will have 40 values because there are 40 days. And now we call another function, which is the plot function. So I close the image that I had opened there with close all, which means close everything, every figure that was open. Because if I wouldn't close it, it would anyway start plotting on top of it. You can try it if you want. And now we can call the plot function, and it's the plot of the mean, and then the variable is patient data, and the mean is across the first dimension. And basically, yes, we get the same that they get. Of course, we need to label our axis. So we want to have the title, which is the daily average inflammation. And you can do the same. Then we have X label, which is the day of trial, and the Y label, which is the inflammation value, or average inflammation, I would call it, but it's okay. Average across participants. All right, so now we labeled our axis, and we have exactly the same figure that they have in the teaching material. All right, so well, basically here they just say what I already mentioned, and we can, of course, so now specifically we plot the average, but we could have also plotted the maximum or the minimum. Now, what is interesting here that the max function is not exactly like the mean. So if one checks the help max, the dimension is actually specified as a third parameter. So the second parameter, so these are all parameters, all the list of variables that we pass to the function. So in the mean, the dimension was just passed after the data, but here max also can be used in the sense that you pass two data variables so that the second parameter can be data. But in general, once you know this, you remember, and if you don't remember, you type help, and you know that to get in this specific case, the maximum across all patients for each day, you need to have this notation where it's saying that here is like saying empty vector, so no parameter, no second parameter, and third parameter is the dimension. And then same story for the minimum. Minimum behaves in a similar way. I leave these exercises for you if you wanna do them, and it's good to do them. And basically we will resume this tomorrow. So now we still have 15 minutes left, 16 minutes left. It's good to check the HackMD to see if there are some questions. All right, so for example, this is a good question. Somebody's asking, how can I flip the y-axis? So I'm assuming that we are talking about, let's close all the windows and let's redo images C of patient data. So, maybe you are not happy to have a look at the data that goes in this direction because you want to have that the patient number goes, visually from the bottom to the top. So you can do this type of visual changes with more advanced commands. So for example, with axis command, let's see if I can show both of them. XY would do this type of flip. So now I typed this a little bit more advanced, but it's good to show you, what is possible. So now I didn't actually change the data with this command axis XY. I just changed how the data is visualized. So the figure gets affected. Basically, I changed the direction of the axis. So now the data stays the same, but the axes are flipped. However, I could have even done that I changed the data so that I could have defined a new variable called patient data flipped and make it equal to flip upside down. It's another Matlab function. So that it would basically flip it like we just see here, that the first row becomes the last row and the last row becomes the first row. So, but now by doing this, I'm actually touching the data. Instead, with the solution axis XY, I just touch the figure. The data stays the same. So we can answer to that. How do I paste multiple lines of code? Well, of course, it depends where you copy them. I think the issue here, I mean, in general, if I select from this teaching material, it pastes also this prompt, which might give an error, and I can try myself. No, actually, Matlab was clever enough. So here specifically, I did Control-C, so copy, and then in the terminal, Control-V, or Command-V for Mac. But this also goes to what I was mentioning earlier, that sometimes the shortcuts in Matlab are not the same as your operating system. So it's good to go and check into these preferences, shortcuts, and make sure that you have, for example, the same shortcuts as the operating system. Check, sure. I'm trying to upload the video. Well, I'm right now in a place where my internet connection is not as good, but I should be back to the office, for example, by the end of the week. But worst case scenario, everything is uploaded after the last lecture. So in 10 days, a little bit more. All right. So I guess we are basically good with the timings. And maybe the last thing for those who are still around, you already, those who wants the credit, I saw they already sent me a direct message on chat, so I have your numbers. And so here, maybe if you want to use 1 minute, you can specify some anonymous feedback, write something positive and something that could be improved about today's session. So now if you can all go, this is important. So even those who don't have the HackMD open, it would be nice that you can also visit the HackMD. I can repaste the link in the chat if you didn't have it. And so, you know, as usual, it's good to get feedback because it's silly that, for example, at Aalto, they ask for feedback at the end of the course because there's no way for, you know, improving while the course is happening. So I try to keep it right now as simple as possible, that, you know, that even somebody who has never programmed in their life would be able to start with these examples and find self-help and self-learning. But of course, you know, we are all different and you might have different needs. So it's good that you are explicit about, you know. So basically, in general, write here something good, something that could be improved for. And if you have suggestions or comments for the next sessions, so tomorrow and the week after that, feel free to write everything down, because then I can take them into account. And HackMD is anonymous unless you make clear who you are. But in theory, you know, I'm not able to see, you know. So yeah, the usual things you can comment on you're already writing about the pace and about the material, and it's not the first year that I'm running this course, so it's easier that I know what to expect and what are the timings. But of course, it's always good to improve it compared to, you know, every year the listeners are different, so it's good to get your feedback. All right. Well, then we are kind of done. Maybe I wouldn't now spend the last minutes to discuss more about what we can resume tomorrow about these exercises for the plotting. Maybe one practicality that I mentioned is that I need to move the session of the next Wednesday. And so if you didn't have time to vote, I see at least 12 people have voted. I paste in the chat again the voting link. So the voting, you just select which days are good for you. It looks like the Thursday is winning right now. So I will of course email this change because there are people who are not here right now, but it looks like that the Wednesday 18 will actually be moved to Thursday 19. At least 12 people out of how many right now? 24 have expressed their opinion. But yeah, if you didn't vote, it's also good. I pasted the link in the Zoom chat, and from there, basically the link is this, and you see, you just click which times are good for you. All right, I'm gonna stop recording right now, so you are more kind of